Hello, good afternoon, everyone, and welcome back. We are going to go ahead and get started with session 9, Object-Oriented Programming 101. Before we hand it over to our session speaker today, I do want to go over just a couple of administrative items for those who are just joining us or missed our kind of intro announcements for other sessions. Please remember to stay muted throughout the session and minimize interruptions and distractions for our speaker. And then also, if you do have any questions, please put them in the Q&A. Please put them in the Zoom chat so we can answer them during our Q&A portion of our meeting, as long as time allows. And then throughout some of the other sessions, we have had some team members in the Zoom chat itself answering via text. So that's an option there as well. So just look out for that throughout. So with that, I am going to go ahead and pass it over to Chris Martin, Senior Data Engineer on the QDAS team. And he can take it over. Maybe. Dan, do you know, I see you're on still. Do you know if Chris is on? I have about 200 attendees or 158 attendees, so I can't see him right now.
I don't see it right now, but I'm sure he probably is. I know that he's always had like mic issues recently with some of our other meetings. So
we can give it another minute or two.
Julia,
I myself had
you should
some
also
Zoom
be able
issues
to
last week.
You should be able to search him in the participants.
Okay, thank you. Sorry, I'm also working on two screens here.
No worries. I know it's not easy, especially when your screen.
I do not see him on. Yesterday in the middle of a demo, my Zoom crashed. I'm hoping the same didn't happen to him.
I'm sending him a message. He's just having some technical difficulties.
Okay, thanks, Miriam. We can go ahead and give it one more minute. Just debating.
Yeah, I'm sending him the link now. I think he got the wrong link.
Kicked out.
Yeah.
Thanks, Derek.
No problem.
the overall data camp was going too smoothly.
Yeah, I know. Yesterday I was sending Laura panic text when my Zoom crashed, but then the same happened to her and Rachel, and they were both my backups. I was like, oh my gosh. But luckily it came back on, so.
All right, he's on now.
Okay, awesome. Thanks, Derek.
Yeah, my apologies.
No, that's okay. I was saying yesterday I had a Zoom crash myself and was full panic, so. Chris, are you still there?
So,
okay,
yeah,
now I see you. All right. Okay, that sounds good. So I'm going to pass it over to you at this point. I did give your title and everything and ran through that. And then, so I think we're ready for you now.
Okay, awesome. Thank you for that. I'll just go ahead and send the screen share request there. And
you may have to request again.
Here we are.
If hers was still active.
Okay. Let me see if let me know if you can see.
Yep, we're good to go.
All right, fantastic. So this is an introduction to object-oriented program. It's not intended for you to learn object-oriented programming outright, but for you to have a understanding of how OOP is set up and how it's used so that you can be able to understand and follow along the documentation and how things are done in Spark and more or less Python in general. So with this, the knowledge goals here are understanding what is an object, what the concept of an object is, the understanding of the idea of inheritance as it's related to class, methods, and attributes, and then being able to read the source documentation as it relates to Spark and be able to follow along with that and understand, like, okay, what does this data frame dot thing mean, or what does this mean when it has parentheses on it, that type of stuff. As far as like a prerequisite for this, you could say the SAS transition office hour sessions would be kind of the starting point before getting to here. Basically, so here we have our outline. We're going to go over what's an object, what's a class, understanding documentations, modules within Python, and what does the import statement do? What are some common objects? And then we'll have some vocabulary, notes, some best practice, and a few additional resources to dive deeper into the topic in general. All the code here will be Python code. So it'll be Python code with this syntax as far as classes and attributes, methods, inheritance, everything we'll go over, it'll be within the confines of the Python world. So OOP, concepts and explanations. In Python or in OOP in general has a concept of an object. What is that? An object is a specific instance of a class. And we say an object, basically, the vocabulary here is instantiated from a class. So you define a class, and then you create all the objects you need from that class. And each of those objects represent an instance. So the different objects usually have different values that differentiate them from other instances of objects. In this example, I give you kind of a generic object here, a car, for instance, and you define a car object, you instantiate a car object, and because of the class, it has these what we call methods. Methods are pretty much functions, but it's just that they belong to the class. So that each object that gets created has those same functions attached to it. Here are car methods. We have like a start method, a honk method, a cut off, a turn on method. And then with the turn on, you can give it a value of what it is specifically that you want to turn on. So here, left signal. But these are things that do something. On the other hand, object has attributes. Here, these are more like static values. So something that just returns like some piece of information. So you can get the mileage, the make, the model, the year, say it's 2024 Mazda Miata with 5 miles on it. So you can get that information just by referring to the attributes, and then you can make the car do stuff by calling the methods. This syntax here where you have object dot property or object dot method, or in here object dot attribute, that's called dot notation. So it's just a period, but you refer to it as a dot. And with that, it gives you the way to like access any other things that may belong to that object. And you may have noticed in your coding in different languages, this is not something that's exclusive to Python. Many other languages use this syntax of dot notation. So you may have, this may feel familiar to you already, but that's what's actually going on, is that, hey, this is an object and it has some other things that are accessible to you that you can use and set and refer to. Also, there's a syntax called chaining. I don't show that here, but in some cases, this object has this, let's say, a sub object. So you can do mileage dot something else dot something else. And it's a convenient way to access and get a lot of things done in a single line of code or in a more of a compact fashion than say, okay, write one thing to do one thing on one line, then go to the next line and kind of start over and do the next thing and so on and so forth. Sometimes it's convenient to say, let's say mileage had a method on it called add, and then you give it, add 1,000 miles because the mileage was off by 1,000 miles. So there's things you can do like that. Here, I'll give an example here, like change it from miles to kilometers. So you call, let's say mileage had this method called to_kilometers, and what it'll return back that you can save that information to some other variable is that same mileage in whatever the equivalent kilometers are. So that's what an object is and how you can work with an object within Python, kind of high level. So object is more of like the lower level item. The higher level item that objects are created from is called a class. So what is a class? In programming, it's really a data type definition. I know we're probably familiar as far as working with data, working with strings, integers, floats, that type of thing. But in programming, it can get more complicated than that. Of course, you can have data types of any kind that have a lot of different properties and methods and attributes. And they all come from the class definition. So a more simple way to think about a class is to think of it as a blueprint that things are built from. So you can take a single blueprint and build multiple buildings, like think of like a subdivision. Got the street with the cul-de-sac, and let's say the developer has 3 different blueprints. So they make, a combination of those 3 different kinds of houses on that street, but it's like 20 houses on that street. But they're all kind of built off of one of those 3 blueprints, and maybe they used a little bit different materials, a little bit different color palette, things like that. Different kind of doors, different kind of finishings in the kitchen and the bathrooms and stuff like that. So each house in that example represents an individual object, but the blueprint represents the class of, basically how the thing is supposed to be built. So we have that in programming with our classes. And here's an example in Python of a class definition. So using a vehicle as an example, just continuing on from our car example, basically, we have a vehicle class. It has 2 attributes, make and model. And then these are the methods. It has a start method and a stop method. And it just prints out, if you start the vehicle, it just says vehicle started, or if you stop it, it prints out that the vehicle has stopped. But when you create this class, you'll give your instance of your object whatever the specific make is and the specific model. So I kept it to just these attributes to keep the code example short. But hopefully that conveys the idea of like how a class is set up in Python. This def init, this is short for initialize. So this just tells Python that outside of self, that this class needs to be defined with a make and a model. And then you attach self. Self is representative of whatever instance you're about to make with that class. So you just set it up with that, making that model. And you can think of this as a base class. So generalization means you make your classes to be more or less generalized. So like this vehicle class has stuff that's common to probably all vehicles. All vehicles start, all vehicles stop. When we're talking about automobiles, and they tend to have a make and a model. So that's pretty common stuff across vehicles, no matter if it's a if it's a SUV, a commercial truck, a sedan, so on and so forth. Inheritance is a concept where you can make what would be called subclasses from the base class. So in this instance, electric vehicles have some different things going on than regular gas vehicles, right? So, for instance, the battery capacity, right? Let's say we wanted to have an electric vehicle class that builds on the normal vehicle class, and what we add here is a kilowatt hour per attribute. So this will tell you how many kilowatt hours the electric vehicle has. So you get a make a model, you can start and stop it, but it also has battery capacity included here. And in the definition, you also have to initialize the parent class. So that's what a class is. Overall, it's a blueprint that other objects in the code are going to be created from, and it'll have all the attributes and methods that are listed in the class definition. Understanding the documentation. So with have an idea what classes and objects are, now we can kind of look into documentation. We should be able to identify what the class is. And one way, if they're not pointing it out explicitly, like they'll say, a lot of times good documentation will say like this is a class, or have class and then the actual name of it. A normal kind of practice is to use uppercase or proper case for class names. So like if you have a vehicle class, capitalize the V, person, capitalize first letter, so on and so forth. From these classes, you create these objects, and then if they're subclasses, they'll have inherited methods and attributes. Again, the inheritance is when a subclass basically is extending the definition of a base class. The base class may also be called the parent or a super class. Same thing with attributes. The attributes are the static values to be set or defined, but they're inherited in the subclass from the base, super, or the parent class. You can identify the methods in a class definition because they're basically function definitions. If we look at this, def is like the keyword, short for define, right? This function has a name called start. So it's defined within the vehicle class. And you can tell because it's indented over. Everything that's indented over is like a member of vehicle. So this function and this function, these are both methods of the vehicle class. So whatever object is created will have that method created on it as well. And then identifying the attributes, these are normally defined in the init function. This double underscores kind of indicate that this is something that gets automatically triggered or run when you actually create an object from the vehicle class. This is something Python that tells Python, hey, I need to run this and set these attributes. So look in the init function and you can see what the attributes are that are being defined in that class. But it's static stuff. It's not a function that does anything. So make is not a function. It's just a value. Model is just a value. So we'll be able to look through documentation, whether it's Spark or any other Python library or tool that you're using to kind of see what the classes and what their attributes and methods are, and understand and follow along like what they're supposed to do based on what the documentation is saying. Spark specifically, they have a lot of information to help developers and people working with Spark. So I'm highlighting their quick start guide here. Within their quick start guide, they have a quick start on the data frame object or class rather. And here it just gives you it just starts telling you and explaining like what the data frame is, what it does, just relevant information to the data frame. They talk a little bit about initializing a Spark session. And then one thing to point out within the Databricks environment is you don't have to manually start your Spark session connections and stuff. So this part within Databricks, you can actually like skip this and get, faster, get to doing your analyses and stuff quicker because you don't have to worry about the connections to Spark. But they go over that anyway, because this is the documentation isn't with respect to Databricks, it's just Spark by itself, how it works, and they're giving you a quick start. Then they go on into data frame creation. You can kind of see with respect to the topic that, oh, this is using that dot notation. So they're saying a data frame can be created via this thing. And we know, okay, this looks like an object dot class dot probably a method because it's doing something. In this case, create data frame. So think actions or doing something method. If it's not, then attribute. So it tells you you can use that method and pass it a list of tuples, lists, dictionaries, and a row class. So PySpark.SQL.row, I know it's a class because the R is capital. You can even pass it Panda data frame. So it's flexible. They made it flexible, but you see they're using this OOP kind of notation here to explain to you how things are interacting. Then they also give you example of code. You see there's from something, import some other thing. So that's one syntax. And then import pandas SPD, so a direct import of something. That's another syntax. But they all end up doing the same thing. But we're going to go over the difference between doing a from import this versus a import this, and then using this as keyword as well. So we'll clear that up as well. But that's an example of their quick start guide, just the beginning of it. API references. This is more in the weeds as far as like the actual code and trying to figure out what different things do. As you see on the left here, it has within PySpark.SQL, then it has all these classes. Spark session, a catalog, data frame, a column, observation. So you may be coding and the object that you're working with is an instance of an observation class. So then you can go here and see what methods and attributes are available on the observation class. What does it do? What can you do with it? So on and so forth. But here specifically, I chose the data frame as an example. But we're not going to spend too much time on this page per se. There's a lot of stuff that it's really beyond the scope of today's talk. But the key thing here is it's telling you here that it's a class, and the class is called data frame, and that it lives on the PySpark.SQL object. So that's really the main takeaway of this page. But if you scroll down more on this page, it has a section for the part that we really, really care about, which is the methods and the attributes. So looking at the methods, they give you a list. It looks like alphabetical list. It says there's a method. So if you have a data frame, you can do .ag with the parentheses, and then give it the whatever arguments it has. So, and then it tells you kind of a definition of what this is: aggregate on the entire data frame without groups. So it's a shorthand for, let's say you have a data frame object that you define, you could do .group by method, and then on that chain the .ag method. So this is just a short form of that, where you could just you can skip the .group by basically and do df.ag, and that will give you the same result. I'll go over alias real quick. Just returns a new data frame with an alias set. So you can go down this list they have. This has a ton of methods. So there's a lot of things that are available. And the good thing to do, the good reason to look through this list is because there may be something you're trying to do and you're trying to manually do it, but there may be a method that does it for you all in one line. So that could be really helpful and really a real convenience and time saver for you. If you know that, hey, the data frame object already does this thing if you call this method versus you having to write 20 lines of code to accomplish the same thing. And then there's also a section for the attributes. So like there's just stuff you need to know about the data frame itself, like D types, for instance, this will list you out all the column names with their data types as a list. So you can see that and access it real quick, because you might have an issue where you're trying to add some things together and it's not giving you the right thing. And it's not giving you the right thing because it defined the column as a string instead of integers, for instance, for whatever reason. So it'll help you debug and understand what your data, how it's interpreting the data that you gave it, or how it defined everything. So there's just a list of these attributes that can give you some static stuff concerning the object that you created. So that's kind of a taste of the documentation. Not all documentation in general is written like this, but PySpark looks like this, and this is actually pretty convenient. You just find out whatever your class is that you're working with as far as the object that you have. So I'll also show how to find out like what type or what class your object is made from, so that then you can go back and look and find out more about it through the documentation. So before that, looking at this, we saw these import statements up here. So now we'll talk about modules, because that's what's relevant for that import statement. From official documentation on Python's website, a module is a file containing Python code that defines different functions and variables and has whatever manner of statements that are needed for that specific module. But basically it's code in a file that can be imported into other code. So you're writing your Databricks notebook, you're coding, you're doing things in there, and you write import some library because it has some functions that you need to perform some calculations. So that thing you imported is a module. And the more thorough definition or explanation for what the import statement itself does is it's a keyword that tells Python to read the code of the module into memory and make it accessible in your code or whoever's calling the code. It also executes any initialization code in the module that is defined to run with. So maybe there's some variables that need to be set up in that module first for that module to operate correctly. That code will be in there and it'll actually get executed. And then all those function definitions or class definition, all the other stuff that needs to be set up, those things will be defined and made into things that you can refer to in your code so that you can use them how you need to. And examples of this, or the syntax. So the importance of having the ability to import things with these different syntaxes is being able to manage your namespace. So when you do import my module, for instance, then you have this object or this module called my module that you can refer to, and you can use dot notation. So it's using more object-oriented programming ideas there. So like, for instance, if there's some parameter in my module that you need, you define my param and set it equal to my module.param. So this is a very common way of importing things. The other common way is from my module, import a specific thing. Here I just call some class. Basically, if you use the first way, you're referring to the my module first, and then using the dot notation, and then grabbing the thing that you need from that module, and then setting up your own objects and variables. With the second, it gives you a little bit convenience for less typing. You can just call the sum class directly. So here I had to do my module dot sum class and then whatever value giving my object. Here I can just say sum class, whatever initial values, and now I have my object. This is important though from a standpoint of you can be importing many things, and if you import, different modules can have the same names for stuff. So some class can be in my module A, it can also be in my module B, and it's called some class for whatever reason. So you want to manage that. Let's say you can just import the top level module so that your code would read my module A dot some class or my module B dot some class. So then it's explicit, like, okay, this is some class from this module versus the other module. Or you can use aliases. So I'll just go over this little last piece here where we're managing the main namespace, and what can happen is you can overwrite something that's already there. Like Python has a lot of built-in things in its namespace. So it has a lot of built-in functions and stuff. List is one of them, for example. List creates a list out of something that is iterable. So, or converts some other iterable into a list object, iterable. Well, you can actually overwrite that. You can, in your code, you can write this line of code, list equals orange. And then once this has executed, if you try to use list to create a list of something, it's not going to work. You'll get an error that says string object has no, is not callable because it's not a function. It's a string. It's just orange. So you can run into issues with that. So that's why you want to manage your namespace and make sure you're not overwriting things accidentally, because then you'll end up getting undesired results or errors because you're trying to do something with something that's not what it is anymore because it's been changed. With aliases, let's say I'm trying to do this from my module, import some class. I can put the word as, kind of like SQL, as something else, SC or mod A class or whatever, just some other name. One of the things you'll see in a lot of people's code when they're using pandas is they'll import pandas as PD. This is really more or less for convenience because you can just do PD dot whatever instead of having to write out the whole word pandas. But everywhere you see PD, you know that it's referring to pandas, and you still have access to all the same attributes and methods and everything that pandas has to offer. So that is the overview for what a module is, how you import a module, how the namespace is affected by the imports, and how you can pay attention to what the things you're importing and what they're called so that you don't accidentally overwrite something else. Comment objects. So basically in Spark, the two main things you would be working with, and within the context of Databricks, is really just one. The session object, so that's created from that Spark session class to connect to Spark clusters, but Databricks kind of handles that for you. The other is the data frame object. So you're bringing all data in and you're creating this data frame object, and that's what you basically do most of your data work in within the context of. And again, that data frame has many attributes and methods available, statistical stuff, SQL-like stuff that will help you be able to do whatever it is that you're trying to do with your data within PySpark in the data frame. So with that, I want to kind of show some of this stuff in action. Basically, the class, object, and the inheritance and the generalization concept. So in this first cell, we're going to make that car object from earlier, right? So we have defined here a vehicle class. We initialize it with a make and a model. And if you dig into like the code, if you did want to do that, they have like for open source libraries like a Spark, PySpark, they'll show you like on their GitHub page, like all the code that's there, and it'll look like this. So that's why I'm also showing that. So like if you go that far, you can see it and understand it. So it'll have like class data frame, and then it'll have this stuff in it. It'll be a lot more stuff, but it'll have this stuff in there. It'll look like this. So here we initialize with our make and model, and we set the actual self represents the instance. Basically, it's like a placeholder for the instance to be made that's going to be made in the future. So we're saying the make that we pass in, we're going to set the make of the object to that value. Same for model. Then we define some functions here that do something with the instance of the object itself. So here we're printing self.make started. So we're going to get a message back saying, if let's say I had a Mazda Miata, so I define a Mazda Miata vehicle object, and it'll print out Mazda started. Then similarly with stop, it'll say Mazda stopped. So with this class defined, we're ready to create our object. So here I create a vehicle object. So I call the vehicle class. I pass in the make and the model. I got a Ferrari SF90 Spider. So convertible Ferrari here. And I just save it to car. So car is now my new object that is specifically a Ferrari SF90 instantiated from the vehicle class. So then I do a print. I say just print what is the make, what is the model. Let's start the car. Let's stop the car. And then here, actually, this should say that. This is how you find out, like, what is my object, like, what is it made from? So here you see even hovering over it. Let's see. Oh, this is giving me information about the type function that I just typed in. But when I run this, you'll see, oh, type car is a vehicle class. So let's run this. So here we got our Ferrari make printed out, our SF90 Spider model. The Ferrari started, stopped, and our type is class, main vehicle. So then note with this knowledge, then let's say I had a documentation website, I could go back to that website and look at the documentation for the vehicle class. So if you're ever curious about a certain object in the code, you can run this and find out what type that's really made from, or what class that's really made from, and go look it back up in the documentation. Here is a example of inheritance. So here we have an electric vehicle class that inherits the attributes and methods from the vehicle class. So when I initialize this electric vehicle, I pass it the stuff that would normally go to the vehicle class along with some extra stuff. So here I added kilowatt hours. I also added a driver as well. But then here I'm also initializing the parent class, which is the vehicle. And all I'm passing it is the make and the model that was given when you initialize the electric vehicle. Here we go on to use our electric vehicle class and create an electric vehicle. Driver, actually, let me take driver out because that kind of muddies the waters. We don't want to see the driver. So this is how this should look. Actually, take this class out as well. Okay, so much simpler. So all we're actually adding here is the kilowatt hours, which represents the battery capacity. So we've added that, and then we passed the make and the model, which is from the base vehicle class, and we're passing that to the init function for that class. So then to create our object, all we got to do is call our electric vehicle class, give it the make, give it the model, and also give it the battery capacity. Then when we run this, we'll see the output of these things. So here we have the Rimac Nevera battery capacity is 120 kilowatt hours. We started it, stopped it, and we see that this time the class of our vehicle is a electric vehicle class. So again, we could use that and go to the documentation and learn more about what else is available. What can we do with this? Is it a subclass? So on and so forth. All right, with that being shown, just real quick, vocabulary notes. Basically, these are the main keywords. Class, we know what a class is. The blueprint, the object, that's what is created from the class. Inheritance represents, it refers to when you make a new class from an existing class, basically, and add extra stuff. Instantiation, that's the more official term of how an object is created from a class. Best practices, just basically protect your namespace. Watch what you're importing, and you give it the names or use the method that best suits you as you're building your PySpark code. And then we have some additional resources, the Spark documentation itself, some resources on classes within the context of Python, namespaces. So because namespaces has like a hierarchy, and there's a lot more levels to namespaces. Today was just a real super high level on namespaces, but it's definitely deeper than what we talked about. And modules. So this gives you a really good, clear dive into modules and what they are and how to use them. So with that, I'll open the floor for any questions.
Right now, Chris, I haven't seen any come through in the chat yet, but we can give it a couple more minutes too.
Okay. And let's see.
I think everyone's absorbing,
So hopefully,
and this should be a
Okay.
really nice resource for
understandable.
people to come back to as you dive into documentation and try to understand it better.
yeah, absolutely. Hopefully try to design it that way. So, oh, you're talking on mute, Julia?
Yes, I am. I said we did get some good feedback in the chat though, so that's good. Okay,
Awesome.
so in the meantime, do you want me to share the deck again for like the wrap up stuff? Oh, here's a question. Has there been a good use case for OOP and CMS systems?
I don't think I know that myself. So I would call on some backup for that one. I could say from
I mean-
if you're using SAS. Oh, go ahead, Dan.
I was just gonna say, I mean, it depends on what your definition of CMS system is, but basically, I mean, Databricks itself is stood up on primarily all OOP. Like everything that we're working with is OOP. When you talk about function like design work, and most way that code is written is it's either functional or OOP, and OOP has really been the most prevalent. Although there are arguments for functional as well. So I can't say specifically other than like I said, Databricks, what we're using right now. And our specifications of it and our entire environment is basically OOP.
I got a message directly that said I would say the best use case for OOP for most folks attending the camp is the decommission of SAS. Which I don't totally know what that means, just because.
And
Yeah, I mean,
and
so
from my personal
yeah,
oh, go ahead.
just like the concept, of object-oriented programming, it covers a lot of programming languages like Java, JavaScript, Python, R, MATLAB, there's Visual Basic. There's a lot of stuff that's object-oriented programming that is utilized to build applications, to build systems, it's the idea of this is really just to understand the differences between SAS and an object-oriented programming language, right? And how you can create functions and define them within classes and then package them as modules, which can very much be just like SAS macros, that all of your entire team can utilize for common functionality, common code. And like that's the concept. That's the idea of kind of the introduction to object-oriented programming and how that can kind of service as a sort of auto exec within SAS.
And
Thanks,
I'd just like to add that when we were designing this coursework or this presentation, the main idea was not that we expect everybody to become masters at object-oriented programming, but we wanted you to have enough understanding so that when you can feel comfortable looking at the source documentation itself and understand what is happening, and what are you using and how can you piece things together and really become more confident in the resources that you have. And then, thank you very much, Chris.
Thank you.
no
So
problem.
Chris, if it's okay with you, since we're not getting more questions, I'm gonna go ahead and slide back to our deck. Because we have a couple of wrap-up
Okay.
slides there.
All right. So
Okay. So the next item on our agenda here is a DataCamp feedback survey. So quickly as we pivot from kind of like the session 9 into our like final closing items, just a quick thank you to Chris and all of our attendees who attended DataCamp, and really all of the team and everyone behind the scenes who helped make it so great, and all of the organization that went into it. I know it's a lot, and we appreciate the attendance and the support. So with that, we have our DataCamp feedback survey. We're gonna go ahead and drop that in the chat now. So this survey helps us know how we can improve DataCamp in the future. The survey link's going to be shared in the Zoom chat. We encourage you to take the survey now, or directly after DataCamp ends, and it's going to remain open through the end of the day. But because it is already almost close of business, I think we're gonna go ahead and keep that open one more day, at least until noon tomorrow. And then as a reminder, the survey is anonymous, but providing your contact information does allow us to follow up and provide support where needed. So if you have like a session that you'd like to see in the future or get more information on, or you yourself would like to present next time, make sure you're leaving that contact information so we can certainly get back to you there. So with that, I'm going to pass it over to Ken Howard at this point for some closing remarks.
Hey, good evening. All congratulations making it to the end of data camp. I can't thank you all enough for your attendance. I saw some pretty significant numbers the past 2 days, and I'm really impressed with the participation we had in the community. Please consider taking the survey, providing us feedback to the event so we can make it better. If along the way to our next data camp, so we try and have 2 of these a year at a minimum, provide us feedback to what topics you would like to see, what usefulness you would like to see, so we can only get better at this. We provide the information that improves each one of your programs and deliverables. And by all means, any constructive criticism you all have and want feedback, I am open if you wish to reach out directly. Kenneth.howard@cms.hhs.gov. Happy to talk with you, be very open about what we're doing. We're trying to increase transparency and participation of our community. We're, as I stated in my opening remarks, please keep an eye out for some improved governance in our user community participation in that governance, not just presentations, but actual engagement and participation. We're looking at improving that going forward. We have the 13th coming up, a lot of great changes, a lot of new technologies, a lot of new program improvements that we're looking at doing. So stay tuned for more information. Again, don't hesitate to reach out, provide us feedback as you see fit. And again, congratulations. And that closes data camp.
Thanks so much, Ken. As he said, please definitely take that survey. And if you have any issues opening, need any support there, definitely reach out to us. And with that, have a great night, everyone.